All right, then I'd like to welcome everyone back and welcome to our session on auto-generated coherent observability. My name is Dominik. I work as a developer experience engineer for Grafana Labs, and
I'm Arthur Sens. I'm Prometheus maintainer. I maintain other projects overall around observability. I'm also software engineer at Grafana Labs. And let's start with a small question. We have some code. It's Go code. We are creating a histogram metric. We are increasing the value we're observing a request, and that's it. That's the whole script. There is 2 bugs here. This question is not for the client Go maintainers, please. But if you guess correctly what is the bug, I'll give you plushies. I have 30 seconds. Sorry? Nobody? Yes? Nice. I always wanted to do that. Yes, there's one bug. There's one bug left. Okay. No, I don't think that's a bug. Okay, client goal. Yes, nice. So as we can see, method and code, there's a particular order, and when we are setting the labels back down, we are switching the order, and this is not an error. Like it is a error, but like runtime compile time doesn't catch, runtime doesn't catch. We end up with a messed up metric when we deploy this, and it's also the second bug is we're just creating 2 labels and we are passing 3 labels. And since this is not type safe, it just passes. And when we run, we actually get a panic.
yeah, but this isn't just an issue during development time. If you are developing applications and you want to add metrics and you have a free-form string to put anything into, developers will put anything into that string. So things can go wrong, and things can go wrong at scale, which is also called microservices. And in this situation, you will end up with something I like to call telemetry sprawl, which is, for example, I'm debugging an application, I'm taking a look at my HTTP request rate for the front end service, I'm logged in, okay, everything looks good here. Take a look at the backend, and suddenly there's no data here. Now, this could be because of multiple things. It could be because my metric name is changed. It could be because my backend is down. It could be because the service name attribute isn't the right thing to use here. I should have used the job attribute. So, and at this point, I'm no longer debugging my application, but I'm debugging my monitoring system. So we have to come up with some kind of way to agree upon what is the correct name for a metric. What are the attributes? And this is something the OpenTelemetry project has come together to. They've built agreed upon names for common signals.
Like, if we take a step back, Prometheus actually did that first. People like to say I did it first, but yeah, we also have conventions. The problem with Prometheus is that we failed. I wouldn't say fail, but we didn't think about automating these conventions. It's just like, here are the conventions, please follow, and we trust people to do it, and that not always happens. So one thing that I have to give it to the hotel folks, that they actually build a community around the semantic conventions. They build automation, and I think that's a great thing to do.
Yeah, and the advantage of having so many different people working on semantic conventions is that we now have semantic conventions for things like networking, CI/CD, HTTP, of course, hardware metrics, cloud provider specific ones, AI ones. So we get AI into this talk as well. So if you're using some of these common abstraction layers, you already have your work cut out for you. You want to instrument an HTTP service, you take a look at the HTTP semantic conventions, and you're done, right? You check all the boxes. But there are some issues with that. Most pressing issue being that works for common stuff, but as soon as you start with business logic, you're left on your own again. But we're talking about semantic conventions without actually showing them. So this is what a semantic convention looks like. This is the HTTP server request duration histogram out of the HTTP semantic conventions. It's basically just text and tables. So you have a name, you have a description, you have a instrument type, which is also very important because otherwise you end up with different services. One saying this is a histogram, the other one saying no, this is a counter. So agreeing upon a histogram type is important as well. Unit, even more important. Otherwise, there's no way for you to know, is this in milliseconds? Is this in seconds? You have attributes in there. Those attributes, again, have types, have descriptions, have examples, which is pretty useful if you're starting out with a new field and you're like, okay, what should I even put in here? Like, I know what a URL scheme is, but do they expect me to say HTTPS or something else? Requirement levels, also a very important part, because if you're using them to define any alerting rules or specific dashboards, you can rely upon those metrics to or attributes to always be there on your metric. And then the stability level. And the stability level is important for the same reason. If you're depending if your alerts are depending on unstable attributes, it could be that different services are using different versions of these conventions, and one has it as required, one doesn't have it as required. If it's stable, you can generally trust it to be available across the board. Now, these conventions are all open source. There are also conventions for spans and logs and events and everything else. But the cool thing isn't just that you can use them for free, but it's open source. You can also just build your own semantic conventions. Like, you're not constricted to what's out there. Say you're developing software for a library system, you're just going to build your own library semantic conventions. You open up a shared document, you write down your metrics, you write down your attributes. Basically looks the same as what I've just shown you before, just slightly different formatting.
Yeah, sorry. The problem with like creating a shared document, creating sorry. Oh, sorry. Hello, YouTube. Okay, so the problem with building manual conventions, I forgot my line. Second. Okay, so problem with building our own conventions with like a shared document or a website is that it's like there's no automation, and that's the problem that we are seeing in Prometheus. Like, for example, if I have a label in one export and with a meaning, and there's another exporting with another label with exactly the same meaning, it's not uncommon to see they have different label names, and like it messes up joins. It's just a mess overall to use PromQL with different labels. Keeping the documentation up to date, for example, the mixins, the system changes and it's hard to update whatever needs to be updated to be sure that it's up to date with the changes. Okay, I messed up a little bit, but it's okay. It's also hard to ensure that teams adopt. As I said before, we just tell them, hey, here is a convention, please use it, but without enforcement or validating that what they are doing actually follow the semantic conventions, it just spins out of control. So what OpenTelemetry did to don't do this mistake with OTel, they built a tool called OpenTelemetry Weaver. And OpenTelemetry Weaver just accepts schemas. Oh, sorry, I didn't. Yeah. When the OpenTelemetry Weaver accepts OpenTelemetry schemas as inputs, and it uses these schemas to generate text, usually code. It also has a lot of policy validations. For example, I can tell Weaver, please don't allow dots in my metric names. Please ensure the counters finishes with underscore total suffixes. So I think this is a very good addition for Prometheus as well. And this doesn't work well with Prometheus, but if you send OTLP to Weaver, it will validate that the metrics that are arriving, they follow the conventions that you built for your company.
But this isn't new. If you've been to KubeCon or the Observability Day, you've probably seen this talk, Observability by Design, which goes through the entire cycle and demos Weaver for OpenTelemetry code generation. But we still think there's more potential to be harvested here, especially in the code generation part, because while Weaver was intended for OpenTelemetry SDK generation, code is just code. So we can also use Weaver to build Prometheus SDKs or even full-on dashboards and alerting rules out of a semantic convention.
And in fact, the most thumbs up issue in client Golang today is a request for type safe instrumentation code. So there's definitely demand from the community for that.
Yeah, and to show you that Weaver can actually solve those issues, we've prepared a little demo. I'm not sure if we can read that well enough. So this is a simple example, basically what we showed on the first slide. If you're instrumenting your application using the Go SDK, you define a new counter, you tell it a name, you tell it some help text, and at this point we're already, okay, this is a string, a freeform string. What do I put in here? Do I have to coordinate this with someone else? Help text, do I really need to define this here, or is there a better way? Can I reference documentation somehow? Some labels, there's no way to tell this is a mandatory or this is not a mandatory label. And then if we use it, we're going to open up, we're going to instantiate with specific labels. And if we run this code, we'll see nothing works because I misspelled location in here. And luckily, this was caught at runtime during application startup. But if this only happened like down the line, we would have had a production incident here. So what alternative does Weaver propose? Well, Weaver proposes we don't do this at all, but rather use auto-generated type-safe client. So I have this library example as a Weaver schema right now, or a semantic convention schema, and it offers me a new package, a Go package called libcon for my library conventions. And if I want to instantiate a new metric, I just have to call the function for this. I don't have to think about help text. I don't have to think about the specific label name or metric names, labels, attributes, whatever. I just say I want to have a new counter for my index books. And this has code completion and everything else you'd imagine. Then I register it using this standard Prometheus SDK. And when it then comes to defining those labels, I don't get to enter strings. I have to input type-safe attributes that are matched to what I defined in the schema. So I have my location attribute in here. And this isn't just a string, this is a location attribute. So it's hard for me to mess up the ordering because the function signature is I need to pass in a location attribute and nothing else. And then as usual, you just add stuff, set stuff, use the Prometheus SDK as you would have. To prove that this works, I'm gonna restart the application now, and we have a backend here. So this is now generating metrics. And on the, let me see. I put the things on the wrong screen, but I will make do. So this is the metrics endpoint for this application. And if I search for books, I will get a metric following the conventions I laid out before. So never in my code did I specify what the specific things should look like. Oh, this is the indexed one. I have the location attribute set correctly. I have the indexed variable set correctly. So everything is taken care of for me. Now, what does this look like on the generation side? On the generation side, we specify metrics. Now, these are YAML, as everything nowadays is. So I have a metric name for library books indexed. I'll tell it my stability level. I'll tell it a description. I'm going to tell this is a counter metric, what the unit should be. And here's the first advantage. I can reference attributes. I don't have to define those attributes in every single metric I define. I can reference common attributes. These attributes are defined in a file right next to it. So this was metrics YAML, and then we have attribute YAML. Here I define all my attributes for this library service. And one cool thing is if you're using enumeration, you also get code generation for specific values, so you don't have to freeform them as well. To show you that this is all live, I'm going to add a new attribute to my metric, which is going to be presenting at, just representing which conference we're currently at, if anyone has forgotten. Also going to add it to my metric. And now I'm going to run the code generation again. So just make clients. And Weaver went through, generated my new client. If I run this application again, it will give me a compile time, not runtime error, that we currently only have a location attribute, but we also now want a presenting at attribute. So to fix this, I'm going to go into my definition in here. I'm going to add the attribute promcon25. I'm going to fix the import path, run the application again, and we're good to go. And checking out the metrics again, we will have the books indexed with a new attribute in here. And this is what we defined in the schema, and I didn't have to think about naming at all. Now, this is all well and good for client generation, but we mentioned we want to do more with this. So what we did was we also took Weaver to generate dashboards for us. And in this case, I'm going to produce some data. So this is the example application. I'm going to do a few HTTP requests, borrow some books, borrow another book. And then I'm going to run another command to make dashboards. This will use custom templates for generating dashboards. In our case, they're generated using the Grafana Foundation SDK, but this could be any as code tooling you want to. Then I'm going to serve these dashboards for local development. And inside of my client here, now I have two different dashboards. We have the HTTP dashboard because we imported the HTTP semantic conventions, and we also have our custom library dashboard. If I open this up, I get two panels with different metrics in here, and this is all the live data coming in. And because Weaver knows that the required or the presenting at attribute is a required attribute, we automatically get variable filtering, we automatically get grouping, we automatically have different series for each different panels for each
Yeah,
metric.
just want to say that the presenting at the top is not something that Weaver did. It's just us interpreting the schema. We think that the required ones are worthy to be filters.
Yeah, all required attributes. Since they should be on all metrics, we can filter by them by default. We can also, for the templates that we wrote, we added the ability to set custom labels for specific for things that are not part of the schema. So if you're using Kubernetes service discovery and that's not part of your schema, you can still say, actually, all the metrics will have a pod name or a deployment name or something else. So you can add them at code generation time as well. And for the same holds true for the HTTP dashboard. So I only implemented metrics for two things, for client gets and server gets. And the cool part is Weaver knows the instrument type. So this is a histogram. It will automatically generate the correct queries for the different percentiles and make sure that our representation actually looks good and is usable. Okay, I'm going to check how we are on time. Let's see. Yeah, I'm going to do another demo. And this is going to be all about the policy validation aspect. So I showed the metrics file before. And let's say I am developing a new library that is only in the cloud. So we don't have a physical location, but I'm still using the library and the location is a required attribute. So yeah, I'm going to get rid of that just to make sure I can implement my things. So then I'm going to run the check command in this case. And as this is all taking into account what has been there before, Weaver will actually tell me you cannot change this attribute because it was required before. It was a stable metric, so you're not allowed to remove that. And you can imagine this being part of your CI for this semantic convention repository. And in this case, the PR would fail because you're trying to remove an attribute that was required before. And if alert rules are depending on that, suddenly your alert rules are not working anymore. So this is something that saves you from your own mistakes. Now, this was all the demo. How did this actually solve our issues from before? We have our cross-referencing labels. We showed that we have different metrics all using the same attributes. Documentation, we can use Weaver not only to generate clients and dashboards, but we can also just generate documentation. And this is actually what the OpenTelemetry community does. All the semantic conventions you see on their website are auto-generated using Weaver, taking Weaver input or schema input and outputting a markdown document. The ownership process, since it's now everything is as code, you can reuse existing ownership practices like code owners file, different repositories managing different aspects, and then you have clear responsibilities who's allowed to merge something in this repository. And to ensure teams adopt this, now you're generating cool type-safe libraries. Obviously, teams want to use this. You can still use the live checking, but no matter how good of a technical solution you build, you'll still have to actually talk to your teams and make sure they implement it.
Yeah, if you saw the Grafana dashboards, you notice that when we change the metric, we're still not solving the gaps So I think I wanted to mention that the talk that Ariana and Bartek did at KubeCon earlier this year, they are talking about making Prometheus schema aware. So if you are changing a schema, changing a metric, Prometheus understands the schema changes and also fill in the gaps with the metrics that was previously with another name. And to finalize the talk, what I'm envisioning, well, we can obviously not follow this at all, but I would love to see the Prometheus SDKs provide the templating and automation to build type-safe instrumentation code based on schemas. I would love to see Prometheus itself replace the current instrumentation that it's using to be more schema-oriented as well. The exporters do. And I know there are some people that love JSONnet. I'm looking at you, Matthias. But it has been a little bit of a pain maintaining mixins, and I think it's a lot easier to maintain schemas than mixins. I would love to see vendors providing automation. For example, Grafana provides automation to build dashboards on top of schemas. I would love to see Persys doing the same thing. I would love to see, I don't know, Victoria Metrics, Google Cloud monitoring. Every vendor just provide the automation, and we maintainers don't need to do that anymore.
And yeah, that's basically everything we had for you today. I think we're good on time, so if you have any questions, you can either ask them now. We're going to be here all day and all day tomorrow, so yeah, just approach us, and we're happy to chat about Weaver and everything else. Thank you.
This looks very cool. Do you maybe have an idea for a tool to onboard existing exporters to this?
Oh my God, I'm very glad you asked.
I don't want to write all this stuff.
Look, it almost sounds the stage actually. I have a lightning talk that I'm going to talk about this, and I'm looking for Nicholas Takashi. Where is Nicholas? Oh, there you go. Yeah, Nicholas built a tool that can accept metrics in almost every format. Like, let me rephrase that. If you have metrics in every kind of format, you send to OpenTelemetry collector, and it transforms to OTLP. And from an OTLP message, we are able to build the schemas for you. I am hoping that we can talk a little bit about this at Lightning Talks, Nicholas. But yeah, we have some tooling to help that. We just didn't advertise well enough yet.
Awesome.
Yeah, I have a question around ease of use of schema definition. So we want people to stop writing defining their metrics in code, but instead define them in YAML. How you think easy it is right now was for you, for example, to set up this demo to define this metric in this YAML? How we can make it easier for others to really start adopting this?
Yeah, I think this tooling that Jan just kind of requested, I think it's going to help a lot. So we can transform data that already exists into YAML, and then from the YAML we do some adjustments. I think. Sorry, as far as could you repeat the question?
Yeah. Okay. So let's say the tool exists, but people wants to still create new metrics with schema definition with the YAML.
Yeah. Okay. Yeah, I think there are some work on the Weaver side. I think there is a very high learning curve to start using. The documentation has a lot of opportunities for improvements. I think the templating language, not very friendly user, is Jinja. And it's not even Jinja, it's a subset of Jinja, if I understand correctly. Yeah, so it is difficult. We had some problems to set this all up.
But yeah, to come back to the question of defining metrics is pretty straightforward. As you see in the metric file, you basically fill in the same fields you see in the generated documentation. The hard part is really the template part, and that only needs to be done once. But the adding new metrics is easy.
Did that answer? Okay.
We have seen that in monitoring data visualization, it's a very complicated art. It's hard to make things human readable.
Is your microphone on? Is it green? Now it's green. Sorry. So yeah, we see in monitoring that data visualization is a very complex art to get something really meaningful, actionable. We have a lot of best practices, often incubated in the Prometheus community. Do you see solutions to integrate in your dashboard generation or panel visualization generator some of these best practices, maybe to show all together red panels, or maybe to hook navigation from application layer to infrastructure layer, all these best practices that we have integrated in the generated dashboard?
Yeah, this is a good question. Basically, how can we make sure that our institutional knowledge is not lost during this transition? And the neat part, these schemas, they have these fixed and rigid fields of this is a metric, this is a type, this is everything else, but you can also add annotations. I can see a future where we as maintainers just have to maintain those annotations to say, okay, this is a very important metric. This is related to these other metrics. During visualization, put them together if your tool supports this. So Perseus could maintain their set of these things should group together in logical grouping X, and Grafana can put a different annotation on it to say those should actually be rows or dynamic dashboards or whatever you have there. So it would then be a matter on the visualization vendors. It would be a matter of defining annotations and making sure that everything groups together correctly.
Yeah, no, thanks. So with schemas, I think it's pretty cool, actually. I like the talk, thank you. With schemas, my experience at least is that once you adopt a tool like this, then you have over time schema sprawl in the organization, right? Many people exposing their own schemas, then you have versioning, then you have things like, I want to roll back a service and now I need to roll back my schema, and et cetera, and so on and so forth. And then you need a schema registry, and and then things start getting more complicated as you scale. So I'm wondering, like, what have you thought about this? Like, what happens next? And what's your view on evolving things? And after the meta schema change, and then you need to like make breaking changes to all your schemas, and et cetera, things get complicated.
Yeah. So I'm gonna address this in different parts. So one part was how can I, if I roll back my application, I need to roll back my schema, since the artifact of code generation is usually libraries. And if you have a previous version of your application that still continues to work, like it won't break just because the newest schema version is something different. And one thing I glossed over during the demo, but I can show here as well. One thing we do have in Weaver is the concept of dependencies. And if you have multiple schemas living in different parts of your organization, you can still say, I want to depend on this. So this is what we did in here. We depended on the upstream semantic conventions. And then in our metrics said, I want to import all HTTP metrics. This is not fully working yet. There is some ongoing issues around attributes. But if you see this as its own like software artifact, you have your regular dependency management tooling to link everything together and evolve the schema in that way. And the schema registry is not a complicated new thing. It's literally just a zip file with YAML in it. So you don't have to invest in new tooling to host your schemas. But that's the way we see it working right now.
Other questions? Somebody with a mic?
Yeah, sorry. So so it's important to have like type safe way to send metrics. But like, do you have a way to make sure that the YAML file that you use for definition is correct? Like, I've been using things like if you have a field that is badly spelled, then the builder just ignores it or something, or is it like?
Weaver is a CLI tool and has a lot of checks, a lot of validation. So if your YAML definition is just not following the schema of the schema, then the check will just fail. I would recommend to run this checks on CI. If CI fails, that's probably incorrect.
Yeah, and there's also the aspect, the checking I showed in the demo, where if you remove a stable metric, then it becomes unstable. You can have, so the policy validation is actually written in Rego, so you can write your own policy pipelines to also make sure, since you mentioned misspellings, you can also catch them during the policy validation step.
Okay, thank you very much.
Thank you.